Hey guys, welcome to this session on AWS from Edureka. Today's session is going to be on autoscaling and load balancer. So today I'm going to tell you how you can autoscale your resources so that they become highly available. Alright, so with that guys, let's start with today's session with the agenda for today. So guys, this is what we are going to do today. First, we're going to see what are snapshots and AMIs. So these are basically the entities using which you will be autoscaling your resources. So once you know what are snapshots and AMIs, we'll move on to why do we actually need autoscaling and what is autoscaling exactly. After that, we're going to see what is a load balancer, and towards the end, we'll be doing a hands-on, which is going to be very interesting because I don't think there's a demo out there which can show you the kind of demo that I'm going to show you today. All right, and if you think about it guys, if you're thinking about moving to the cloud industry, autoscaling and load balancing are the very important topics in this in this domain, right? So you should know about them. So if you have been so if you don't know about them, please pay attention today because you're going to gain a lot of knowledge today. All right, moving on guys, let's start with the first topic, which is snapshots and AMIs. So let us see what are those. So I guess most of you are aware of what an EC2 instance is. So for those of you who are not, an EC2 instance is just like a raw server. It's a fresh piece of computer that you have just bought. It's just like that, all right? So on that computer, you can choose any operating system that you want. So once you have the operating system, you can install any kind of software on it. All right, so you have to install every time you launch a new an EC2 instance, you have to install all the required softwares on it. All right, but there's a workaround. What if you want a specific configuration of EC2 instance? Say you want 5 EC2 servers which are exactly like this, like each other, right? So one way of doing that would be to launch a new instance every time, install the required packages every time, and going about it, right? The other way of doing it would be to actually create an image of once you will be configuring your EC2 instance, and after that you'll be creating an image of your EC2 instance, and then using that image you can actually deploy 4 more EC2 servers. All right, so this image is basically what is an AMI. So AMI, which is an Amazon machine image, is nothing but an executable image of your already existing EC2 instance, right? But before an AMI can be created, there's a thing called snapshot. Now, what are snapshots? Snapshots are nothing but the copy of the data, the copy of the data that you have on your hard drive. So basically, if you have your C drive, right, and you want to copy your C drive, you copy your C drive onto some external drive, so that becomes a snapshot. But if you can boot from that external drive so that to your whole operating system comes up on some other machine, then it becomes an AMI. So this is basically the difference between the two. A snapshot is not a bootable copy, an AMI is a bootable copy that you have. All right, so I hope you got the difference between what is an AMI and what is a snapshot. So I'll repeat it again, and you use an AMI to basically replicate an EC2 instance again, so that you don't have to do the configurations all over again. Right, so now you'll be wondering, we were to talk about what is autoscaling, what is load balancing, why do we need AMIs? But be patient, you'll be clear with everything with the session. All right, moving on guys, let's now discuss why do we need autoscaling. Now before that guys, now the way I'll be going through this session is I'll be explaining you each topic and then I'll show you it in the AWS console. All right, so we just discussed what are snapshots and what are AMIs. So let me quickly show you how you can configure or how you can create an AMI of an already existing EC2 instance in the AWS console. So give me a second. I'll just go to my browser and my AWS console. So guys, this is my AWS console. I hope it's visible to you. So the first thing that you'll be doing is you'll be going on to your EC2 console. All right, so in your EC2 console, you will have all your servers that are running right now. Right, so for the sake of simplicity, I've already deployed 2 servers, which are server 1 and server 2. Now I have configured them both with Apache so that they can they can host a website, right? So let me quickly show you how the website actually looks like. So if I'll go to this particular IP address of server 1, this is in path server 1. Right, so this is how the website looks like, right? Similarly, for my server 2, if I go into my server 2, this is how my server 2 will look like. Here it is. All right, so these are my two servers. Now what I want is I will create an exact copy of these servers so that they can be replicated. Alright, so when I say replicated, everything from softwares to this website will be copied onto an image, and that copy or that image, when I will deploy it, it will be deployed inside one more EC2 server in which I don't have to do anything. This website will be there. I just have to go to the IP address and I can see this website. Alright, so now what I'll be doing is I'll be creating an AMI of both these servers. So let's create an AMI for server 1 first. I'll select the server 1, I'll go to actions, I'll go to image, I'll click on create image, and all I have to do is give an image name for it. So let me give the name as live server 1. Right, this is my image name. I'll click on create image, and that is it. It takes in your request for creating an AMI and it does that. Right, pretty simple. Now similarly, I'll be doing it for server 2 as well. I'll select server 2. I'll go to image, I'll create an image, and I'll name the image, say, live server 2. So once I've done that, you can see the images in your AMI tab. So if you look at over here in the images section, you can look at AMIs. If you go to your AMIs, you can see there are two images which are just being created, which are in the pending state as of now. And they are live server 1 and live server 2. Now using these images, you can create any kind of server that you can create the exact same server with just a click of a button. Alright, you don't have to configure anything much. Alright, so this is how you create an AMI. Pretty straightforward, guys. Let's move on and discuss why do we need autoscaling now. So you learned how to create an AMI. Let's go ahead and understand autoscaling and see how they are connected to AMIs. Alright. So say you have an application, you have a website, and every machine, now this website is hosted on some server, guys, right? And servers are nothing but machines. Now every machine has its limitation, right? For example, say this machine is say around 8 GB and say i5 processor. So say it can host around 100 people. Right, only 100 people can come to this website and easily navigate inside the website. But if more than 100 people comes in, this computer or this server becomes slow. All right. So say there are 100 people as of now, and they are trying to access your website, and they can easily access it. Now your website becomes a hit overnight. All right. And now a lot of people are trying to access your website, which makes your server overburdened. Now, in this scenario, you can do only one thing, that is deploy more servers and distribute the traffic equally among those servers so that the requests can be handled. All right. Now, this thing is a manual task, and manual is a big no in the IT world, guys. So we invented a service called autoscaling, and using autoscaling, what happens is it actually analyzes the kind of load which is coming in. Right, and it deploys the servers according to that. So say around 300 people are coming in, and it sees that you need 3 servers to handle those kind of requests. It will do that automatically. Right, and that is where your AMI comes in, guys, because the new servers that you'll be launching, those new servers have to be taken out of some template, right? So the first server has to be the exact copy of the the second server has to be the exact copy of server 1. The third server as well has to be the exact copy of server 1, right? And that is where the AMI comes in. So what basically happens is, in the autoscaling service, you basically attach your AMI which you created, and using that AMI, it deploys more servers, right? This is why AMI is significant, or this is how AMI is related to autoscaling, and this is why do we need autoscaling. Let's move ahead and just give us a definition that what autoscaling exactly is. So like I said, whenever your load increases and you have to scale automatically up and down, you use auto scaling. So it's not only about scaling up. That is, when your load increases, say 3 or 4 servers you have deployed, and when your load decreases, still 4 servers are there to sitting idle, right? So that is not the case. With auto scaling, you can also scale down as per your needs. You can configure everything which you can imagine about scaling up and scaling down in the auto scaling properties. All right, so this is why we need auto scaling. Now, one more thing that you need with auto scaling is, if you would have noticed, I said the number of servers that gets deployed in the auto scaling. Say there are 4 servers which get deployed during auto scaling, right? Now the traffic has to be distributed equally, right? So this traffic which has to be distributed has nothing to do with auto scaling. It has to be done by a separate entity, and that is what we are going to discuss in the next section. But before that, let me show you how you can configure the auto scaling properties and attach the related AMI so that the related servers are launched. All right, so let me go to my AWS console. So here am I, and as you can see, the AMIs have already been created. They are live server 1 and live server 2. Now what I'll be doing is I'll be creating autoscaling groups, or I'll be configuring the autoscaling properties so that these servers can be autoscaled as and when required. Right? So before that, I actually have to create a launch configuration. Now, what is a launch configuration? So if you look at the AMI, guys, you have only specified what kind of data should be there in your server. What you have not specified is what kind of machine you should launch every time there's a need. All right, so that is exactly what you do in launch configuration. So you have the data, but you don't have the information about the kind of machine that you want to launch. So that kind of stuff you will be specifying in the launch configuration. So what I'll be doing is I'll click on create launch configuration, and now it'll give me a wizard as same as that of any EC2 server. Right, in the EC2 server, I had to choose an operating system, right? So same, it'll give me the wizard, but I don't have to go here. I'll have to go to a separate tab which is called My AMIs, right? So I'll select My AMIs, and now I'll select the newly created AMI, the AMI which I just created, which is say we are creating a launch configuration for our server 1 right now. So I'll select the live server 1. I'll click on select. And now it will ask me the kind of the configuration that I want for my server, right? So I need a t2.micro because we are doing a demo today, right? So we don't need much of computing power. So we just have to we'll select t2.micro and we'll name our launch configuration a thing. So let's name it as live server 1, right? And the IAM role is not required, and I'll click on next. Now it'll ask me for adding the storage, so 8 GB is enough for an Ubuntu machine. I'll go to configure security groups, right? And in the security groups, I just have to add the HTTP rule because I have to connect to all the instances that I'm launching, right? So I'll select the HTTP rule from here, right? And I'll click on review. So that is it, guys. Nothing else has to be configured here. All right, and it is asking me to check everything that I've just configured. Everything seems fine. I click on create launch configuration. Now it will ask me for the key pair, right? So every server which will be launched, it will be associated with a key pair which you'll be specifying here. All right, you can create a new one if you don't have already. I already have a key pair, so let me choose my key pair. So that is Hemant_2, and I acknowledge that I have this key pair, and I'll create the launch configuration. It just takes a second or two to do that, and we are done. All right, so now we have created a launch configuration. We have specified what kind of machine we want. We have specified what kind of data should go into that machine. Now we'll be creating the auto scaling group in which we'll be specifying in which cases we want to auto scale. All right, so let's create an auto scaling group now. All right, so it has automatically picked up the launch configuration that we have just created, that is live server 1, right? Let's name this group as live server 1 group, right? and what is the initial size that you want in your launch configuration. That is the minimum number of servers that you want. So let it be 1. And remember guys, this is the most important part. When you are creating a launch configuration, ensure that you're doing it in your default VPC to be on the safe side, because there are a lot of settings that you have to do if you create a VPC on your own, and that becomes a hassle. All right, so if you accidentally delete your default VPC, which I did, right, so you have to contact the AWS support team and they'll help you out with it. They'll basically create one for you. You cannot create one on your own. Alright, so always ensure that you are in your default VPC whenever you're creating your autoscaling group. Alright, so now I'll be specifying the subnets. So basically you have to select a minimum number of 2 subnets, right? I'll be not getting into what are subnets, because then it will be like a 3-hour session. We'll click on configure scaling properties. Now over here you can specify the properties that I was talking about. When do you want your server to scale, right? So over here you can specify the average CPU utilization. Now what do you mean by average CPU utilization? So there are 4 servers running as of now, right? So it takes the average of all the 4 servers, right? And if the average goes beyond whatever number you have specified here, say I specified 70 over here, right? So in that case, whenever the average CPU utilization will go beyond 70, it will launch one more server. Similarly, if it goes, I can configure one more property here which says if it goes below 20%, like scale down from one server. All right, so if there are 5 servers and the CPU utilization has gone less than 20%, it'll scale down from 1 server and come down to 4 servers. All right, and you can also set how many seconds should it wait. Say the traffic is spiking down and up like too frequently, right? So for that, what you can do is you can set a time. So if the 20% mark has been not crossed till say like 5 minutes, then it will scale down a server. Or if the 70% mark of the CPU utilization has been crossed over 5 minutes, it will then only scale up. It will not scale up if at only once for only 1 second it becomes 71%. Alright, so you can specify all of that over here, but since I cannot load test my instance over here, I'll just keep it at its initial size, which just means that it'll, even if I delete my instance, that is, one instance has to be there in any case. If I delete the instance, it will automatically launch it again. Alright, so let's we'll select the keep this group at its initial size, and we'll go to configure notifications. So I don't want to configure the notifications, neither the tags. I'll click on review and I'll click on create autoscaling group. Alright, so I've successfully created an autoscaling group for my live server 1. Alright, similarly I'll do the same steps for my server 2 as well. I'll click on create autoscaling group and I'll select a launch configuration which was there for my server 2. So I've not done that, so let's create a launch configuration first for our server 2. We'll go to AMIs and we'll select the server 2 part here. Alright, so I've selected server 2. I'll do the same steps that I did earlier, right? So let me give it the name as live server 2 group. I'll click on add storage, configure security group. Over here I'll add the HTTP rule, click on review and launch configuration, select the key pair, acknowledge it, create launch configuration. I'm doing the same steps guys, I'm not doing any new thing here. I've created the launch configuration. Now I'll create the autoscaling group, which is live server 2 group, right? And then the VPC, as I said, should be default subnets, a minimum of 2 subnets you should select. I'll click on scaling properties. I'll keep it at initial size, configure, review, and create the autoscaling group. Alright, nothing much guys. So same things that I did for my server 1, I've done for my server 2 as well. Alright, so since I've created an autoscaling group, if you go to your EC2 dashboard, you would notice that 2 more servers are now being deployed. Alright, so So you can actually identify them over here. See, these two servers are being initialized. So these have just been created by your auto scaling group, because we've specified that a minimum number of one server should be there at all times, right? Now, if you try to go to the IP address of this server, right, you will see that it will have the exact same settings for my EC2 instance. So this is my server 1. Right, so as you can see, a new instance got created, but with the exact same settings. I didn't have to do anything. It automatically created an instance with the same settings. All right, and same is the case with server 2 as well, guys. If I go to my server 2 and try to access it, I'll see the same things over there as well. So I'll show you in a bit. Yeah, so this is my server 2. All right, so my autoscaling group is functioning fine. So let us come back to our slide now. So we are done with autoscaling. Now, like I said, you need to have an entity which will equally divide the traffic between the servers that you've just deployed. All right. So they say I've created 2 autoscaling groups, guys, as of now. Right. Why I have created a second autoscaling group, I will tell you in a bit. But for now, understand that there is an autoscaling group. All right, and inside that autoscaling group, say there are 5 servers, and if a person is coming in, or a customer who has logged on to your website is coming in, how would his traffic be treated? How would he know which server to go to, right? So there comes in the third entity, which is called the load balancer. So what load balancer does is, a load balancer, your customer will basically be coming to your load balancer, and the load balancer will decide based on the usage of your servers that which server is more free, and then will give the connection to that server. All right, so this is basically the role of a load balancer. So like I said, a load balancer is a device that acts as a proxy and distributes network or application across a number of servers. Now, I've been saying it repeatedly that your servers are actually, your traffic is actually distributed equally among the servers, right? But in a few moments, I'll tell you that there is one more way of distributing your traffic. Alright, so before that, let me again stress on the point that this was your auto scaling group, guys. This is just the example that I took in the beginning, right? So there are like these set of users, and they're trying to access your website, and they are being routed to these servers. So this routing is actually done by a load balancer. Alright, now like I said, the traffic which is distributed, it is distributed in 2 types, right? The first type would be to equally distribute them among the number of servers. Like say there are 5 servers, so it will distribute it among the 5 servers. But if there are there are 2 kind of servers now, so your load balancer can identify what kind of request is being made by your user. For example, in your website or in your application, you have a part wherein you can process the image, right? And you have a part where you have your blogging section. All right. So if you want to process the image, you want your traffic to go to a different set of servers which are auto scaled at their own in their own auto scaling group. All right. And if you have the blogging section, you have a different auto scaling group which is auto scaled at a different with a different auto scaling group. But you want everything to go from one single link. So the way to do that is using an application load balancer. So let me just repeat what I just said. So say this set of servers, they host your image processing part. They do all your image processing, and these set of servers, they host your blogs that you have on your application. All right. A user comes in, he just logs on to your website, and he goes to a URL which says, say, edureka.co/image. All right. If he goes to /image, your load balancer will see, okay, he's asking for the image kind of content. So he should go to this set of servers, because these servers serve the image purpose. And if you go to edureka.co/blog, your load balancer will identify, okay, this user, he is asking for the blog content. So he should go to this set of servers. Alright, so all of that is done using your load balancer. If you compare it with the classic load balancer, it does not have that kind of intelligence, right? What it will do is basically all the traffic that it has got incoming to it, it will equally distribute it among the number of servers that are under it. Alright, but with application load balancer, you have this option wherein you can divide the traffic according to the needs of the customers. Alright, now when you have divided the traffic, again the same thing will happen here as happens in classic load balancer, that at this point it will equally distribute the traffic among the number of image servers, right? And similarly, the people who want to access the blog, it will equally distribute the traffic among the number of people who want to access the blog server. Alright, so this is what an application load balancer is all about. So classic load balancer was something which was invented earlier, and these days nobody uses the classic load balancer anymore. People are using application load balancer. Alright, and that is what our demonstration is going to be all about today. Alright, so enough of talks. Let's move on to the hands-on, that is the demo part. So let me quickly show you what we are going to accomplish today. So basically a user will come in, he will have the address of your load balancer, and if he asks for the image path, or say server 1 in our case, he will go to the autoscaling group of server 1. If he asks for server 2, he will go to server 2, but all of them will have the same address, that is using your address of your load balancer. Alright, so this is what we are going to accomplish today. Now for those of you who didn't understand that why did we create two autoscaling groups, is because we want these servers, that is the image processing servers, to be scaled as well, and at the same time we want the blog servers to scale as well, right? So that is the reason we want we created two autoscaling groups. So I created a server 1, which you can imagine is for your image processing, and I created an autoscaling group for server 2, which you can imagine is for your blogging section. Alright, having said that, guys, now let's move on to my AWS console and go to our load balancers. Alright, so what I'll be doing now is I'll be creating a new load balancer, and that load balancer would be of the type application load balancer. So as you can see, I have two options here. Either I can create a classic load balancer, or I can create an application load balancer. So I'll go on with the application load balancer, and I will name it as live load balancer, and the scheme is internet facing. So since mine is a website that I want you guys to access, right, so it could be internet facing. Otherwise, if you are working in a company and that company wants a load balancer for their internal websites that the companies have, you can actually opt for an internal load balancer as well. But since ours, we have a website and we want that to be used, we will use the internet facing load balancer. Alright, and the listeners, it's HTTP, that's fine. And the availability zones, like I said, you have to select a minimum of 2 availability zones, and you'll click on configure security settings. Alright, so now you'll be specifying the security group. Right, so in security group, it's better to create a new security group. Remember, guys, don't include the default security group for your load balancer. It's a good practice to always create a new security group so that you can customize your rules according to your needs. Alright, so I'll create a new security group and specify the HTTP rule, and I'll click on next. And now comes the part wherein we'll be specifying the targets. Alright, now what are targets? Now in application load balancer, guys, targets are basically but autoscaling groups. Right, so target 1 would be your autoscaling group 1, your target 2 would be autoscaling group 2, target 3, target 4. You can have as many targets as you want, but in this wizard you have to specify a minimum number 1. Right, so we'll create a new target group. We'll call it as say autoscaling live auto 1. Alright, and the protocol is HTTP, port is 80. We'll click on next, and I'll review everything. I think everything is fine, and I'll create this load balancer. Alright, so we have not done all the settings, guys. I'll show you how to do all the settings. For now, we have just created a plain load balancer. Alright, so I have created a load balancer which is pointing to a target group 1, and that target group is not pointing to my auto scaling group as of now. Alright, we will do that now in this part. So we have created, I just created a target group called live auto 1. I'll create one more target group which will be called live auto 2 for my second auto scaling group. Alright, so I'll create this and done. So I now have two target groups, that is live auto 1 and live auto 2. Now these two target groups have to point to my auto scaling groups respectively. Alright, now the way to do that, you cannot point them here. You have to go to your auto scaling groups, right? And in your auto scaling groups, you have to select the auto scaling group that you have just launched. So it is live server 1 group and live server 2 group. So I'll go to live server 1 group. I'll go to details, and over here you'll click on edit. All right, and inside edit you have this option for target groups. You don't have to specify anything in the load balancers. This option is only for classic load balancer, but we are creating an application load balancer, right? So we'll be specifying everything in the target groups. So for live server 1 group, we'll be specifying the demo server 1. So demo server 1 has already been, it will be live auto 1, the target group that I just created. And live auto 1 is connected to your load balancer. So basically your load balancer will point to your target group, and your target group is now pointing to your auto scaling group 1, which are pointing to your instances. All right, so this is how it the visibility comes in. So I'll save it. The target group 1 is live server 1 group, and the target group 2 I'll be specifying in the second auto scaling group, which is here, that is live auto 2. All right, I'll save it, and let me quickly verify if I've done everything right. So this is live server 1 group, and this is live auto 1, fine. This is live server 2 group, and it is live auto 2, fine. So my load balancer can now see the auto scaling groups that I've just configured. So let me quickly go to my load balancer. Now comes the part, guys, wherein I'll be specifying when to go to auto scaling group 1 and when to go to auto scaling group 2. Like I said, we'll be specifying it using the kind of request that the user has made, right? So the way to do that is is by first selecting your load balancer and going to listeners. So once you go to listeners, guys, you will reach this particular page. Now in this you have to click on view or edit rules. Right, so once you click on view or edit rules, you will reach this page, which is kind of an if-else, if-else structured. So now what will you do is, so you can see that there's a default rule as of now, that any request which is made, it will go to live auto 1. All right, which means any request which is made, it will straight away pointed to the auto scaling group 1. Now we'll specify if the request if the user is asking for server 2, he should be pointed to server 2. So let us do that. The way we'll do it is like this. We'll click on add rules. We'll click on insert rule, and now I'll specify. So you have two options here. Either it could be the routing could be based on your host, that is the address of your website, or it could be based on the path. Now what is the difference? Say edureka.co, this is a host name, right? Now if I type in resources.edureka.co, it'll still point to my domain, but if I've specified resources.edureka.co, and if I write it over here and I specify it has to go to server 2, it will go to server 2. Otherwise, if you type in resources.edureka.co, nothing will happen because you've not configured anything, right? So that is the host path. With paths, the difference is that say you write edureka.co/blog, all right? So that /blog becomes the path. But with host, the thing is, the difference is resources.edureka.co. So that becomes one host name, right? But with path, you're basically putting a slash and you are going into a particular folder. All right, so you can specify the path here. All right, it doesn't matter if you have not specified in your server for different say you could the way you could have done the image processing and blog the other way around rather than having it on two servers was that you could have configured it inside two servers in your root directory, right? It could be server 1 for your image processing and server 2 for your blogs. But I don't want that, because as distributed as your system is, it becomes more reliable, right? And that is the reason we have two different servers for two different set of things. So the way you can route your traffic to both these servers is by typing in the path. So say if I have to go to server 1, I'll type in server 1 /star. So star basically means anything after server 1 can be accepted, but it has to go to the request will be forwarded to live auto 1. All right, so if I have server 1 in my path, anywhere in my path, it will go to live auto 1. So I'll save this rule. Similarly, I say that if it has server 2 in its path and anything after that, it has to go to live auto 2. All right, I'll save it. And that is it, guys. Now my load balancer has saved its settings. Let's hope for the best and try executing it. So this is the link, guys, right? If you just type in this link, it will by default go to server 1, right? So if I go to this link, you can see it is going to server 1 as of now. But if I specify /server1, it will go to my server 1, and if I specify /server2, it will go to my second server. Now you might be wondering that Hemant, you might have a different directory in your same server. So let me clear your doubt according to that. So what I'll do is I will go to my EC2 dashboard, right, and I'll go to server 1 and I'll quickly show you what happens if I type in server 2 here. All right, so this is the IP address, right? So if I type in this IP address, I'm going to server 1. If I type in /server2, it will give me a 404 because there is no folder called server 2, right? Same is the case here. So if I go to this IP address, you can see server 1. If I don't specify anything after my address, it will still go to the same server that is here, that is this IP address, right? But if I specify /server2 over here, it will not be able to do so because this is not a load balancer, it is directly your IP address. But over here, if I specify server 2, it will redirect me to the second server. 1 second. Right, it will redirect me to the second server. And that is all that I need. All right, so with one address, you are actually pointing to two servers, which will be solving your two problems. Now, the real life use case, like I told you, it could be for different kind of tasks. Say you have a blogging section on your website and you have an image processing section on your website. If you want two different servers to host your two different services, you can do that easily using a load balancer. All right, guys, so with this I conclude my session for today. Let me quickly go to my my PPT. So we created we created a load balancer which intelligently identifies what the user is asking. If he's asking for image, he'll go to server 1. If he's asking for blog, he'll go to server 2. In place of server image, I've just specified server 1 and server 2 so that it becomes easy for you to understand. All right. One more part that I missed. Whenever you have specified the path, that path also has to be specified in your server. For example, I said load balancer address /server1. Right, so it will go to your server 1, but then over there it will look for the server 1 directory. All right, similarly, if I specify /server2, it will go to second server, but it will look for the server 2 directory. So keep that in mind. All right. So with that, guys, I conclude today's session. Thank you for attending today's session. Have a good day ahead. Goodbye.